This is Physics 1060 Lab 6 Hints. In this lab, we're going to use pictures of the moon to figure out the sizes of the features on the moon. We're going to use that using similar triangles, and this is something that you learned back in high school, hopefully, in a geometry class. If you have two triangles, that one triangle, if you know that the ratios, if all the angles are the same, then the ratios of the sides are the same. And so, to reintroduce you to this, I want you to first figure out the height of a wall or a building or any other tall object that would be difficult to maybe figure out how tall it is from a tape measure. You could even do a tree if you have a tree in your yard that you've always wondered exactly how tall it is. So, what you're going to need is a meter stick. A lot of you might not have those sitting around, so any tape measure that you can hold straight up and down will work just fine. So, we're going to look at the length of the shadow from the edge of a building to where the top of the shadow is located. And if I know this length, then I'm going to try to figure out its height. And we'll do that by taking a meter stick or a tape measure, holding it up and looking at its shadow and marking out the top and bottom of the shadow. Then we can measure this length. So if we measure this length and this length, it's going to be, the ratio of those is going to be the same as the height of the tape measure or meter stick and the height of the building. So in this case, we're looking at a ratio of the sides, two different sides of two similar triangles. And you can solve this equation for DE. And if you're struggling with remembering your basic algebra skills, remember these two fractions I could cross multiply, so I'd have DE times AB is equal to CB times AD. And then I can divide both sides by AB. And there we go. CB times AD over AB gives me DE. So the values are things that you'll have measured outside, and you plug those in there and get your height of whatever you're wondering what the height is. So now we're going to use the same type of calculation to measure the height of objects using their shadows cast on a quarter moon. I have two pictures here. The bottom picture is exactly magnified 10 times more. So any measurements that we make on this photograph, we'll have to multiply those numbers by 10 in order to get the units the same in both pictures. So the first thing you'll need to do is measure the height of this picture. So I'm measuring the width of the moon in picture units. And so I can do that, and I do a careful calculation. I figure out what it is, and I measure 124.5 millimeters. So I get 124.5 millimeters. So in my calculations, though, I'm going to have to multiply that by 10 and say, if I were to measure that same distance on the bottom picture, it would be 1,245 millimeters. Okay. So now, we need to know where the terminator is. And the terminator is just the line where on the moon it's going from day to night, or the light side to the dark side. You can see that's kind of hard because it's not this hard line that you see because the moon is bumpy. So I've drawn in here in the blue line kind of a approximate location of the terminator. You can use that, or you can try a different location if you'd like. So we're going to need to measure a couple things. One, we're going to need to measure the distance from the top of Python, and Python is this object right here. So I measure the distance from it to the terminator. And then we also need to measure the length of the shadow. And those are the only measurements that we have to do. So myself, I got that the distance from the top to the terminator for myself was, let's see, let me look it up. I got 31 millimeters. You should check and look. Especially if you used a different terminator, you might get a slightly different number. It's okay. I'm not looking for exact numbers. I'm really looking for you to go through the exercise. And then I measured the length of the shadow, and for me, the length of the shadow I measured was 14 millimeters. Now on the next sheet, there's a worksheet where you're filling in all these things little by little. I'll just go ahead and work it out here that the height in picture units is LD over R. So that's LD over R. So in this case, it's L is 14 millimeters, D is 13 millimeters, and R is the radius of the moon. Well, we measured the diameter of the moon is 1,245 millimeters in these picture units. So the radius is half of that. So that's 622. So I divide 14 times 31 divided by 622, and I get a height of 0.697 millimeters. Now, we know that's not the actual height of Python. That's the height of it when we're looking at units of this picture, but this picture is not real one-to-one correspondence with the real world. So now we got to figure out how to get these distances into real-world distances. And again, these calculations are on the next sheet. You can just fill in the things, but the real height, I'll say real height for RH, over the photo height is the same as the real diameter of the moon divided by the photo diameter of the moon. So the actual real height of the moon, real height of Python, I can cross multiply, so I can multiply the photo height. So I'm going to get photo height times the real diameter over the photo diameter. The photo height is just the 6.697 millimeters. The photo diameter is the 1,245 millimeters we measured. We can look up the real diameter of the moon is 3,476 kilometers. If you plug that all in, I get, with my calculations, 1.95 kilometers. Now, I've talked you through this, I've worked through all these. Please do these measurements. If you're off by a millimeter or you get a different measurement, go with your measurement, not with mine. You can follow my steps to figure out how to do the calculations, but I want you to use your own measurements. And it's okay if you get something different than I have. Just work through it, and if you have any questions, go ahead and post those in the discussion board, and I'll help you work through anything that you're struggling with. So the picture on here just shows the geometry of how, and shows you these similar triangles. The angles are all the same, therefore they're similar triangles, and so the red triangle and the green triangle, I can use the ratios, and that's exactly what we did on the previous page. And so just fill out your values for R, L, and D, and the height of the photo, and the actual height on this page. Now here's where I want you to do something different. In that picture, there's lots of different craters. There's a kind of a large crater up at the top. There's other smaller craters. I don't care which crater you use. Just circle it so that I know which one that you used. And I want you to do the exact same thing to look at the shadow cast in the crater to see how deep some of these craters are from the top of the edge to the bottom of the crater floor. You'll do the exact same measurements. You already know the diameter of the pictures and everything, so all you're going to be measuring is the distance from the edge of the crater to the terminus and the length of the shadow. And then I want you to discuss these questions, several sentences each. just think about experimental errors and things like that, and think about, in question number 2 here, how does the height of Python compare to typical mountains in Earth, and especially I want you to look at how skinny Python is versus its height, and think about why it's different on the moon. When you're done, scan all these pages into a single PDF and turn them in on Angel.